For this worksheet, my job is to find the area of the inscribed regular polygon. So in number 1, I have a regular triangle, or which we would know as an equilateral triangle. So I know all three of these sides are the same. You notice that what I drew was the apothem and a radius and then half of that side. So what I know is that the radius of this circle is 16. I'm going to use the area formula that says area equals 1/2 the apothem times the perimeter. And I'm going to use the circle to help me find those numbers. So the first thing I have to find is this angle inside my right triangle. Now remember, we were drawing 3 equal or congruent triangles from the center of that circle. So we know that this angle matches this angle, which matches all of this angle. So if I take 360 degrees divided evenly by 3 parts, that's going to give me a 120-degree angle. Now remember, that's actually the measure of the arc. So each of the arcs that these chords are cutting off is 120. And if each of those arcs is 120, then each of these central angles is also 120. So I'm going to take that triangle and redraw it over here so I can work with it a little bit easier than in the big picture. So that big angle is 120, which means when I cut it in half with the apothem, it gives me 60 degrees inside my right triangle. And if I have a radius of 16, and I have a 60 and a 90, that leaves me 30 degrees over here. That's a 30, 60, 90. So we can use our idea of the 30, 60, 90. Remember, across from 30 is 1, across from 90 is the 2, and across from the 60 is the root 3. That means to go from 16 to the short leg, I'd have to take 16 divided by 2, which is 8. And that segment right there is my apothem. Since we're working with a 30, 60, 90, I do know that to go to this leg, I'd have to take that 8 times root 3, which is just 8 root 3. Here's how I'm going to use those numbers. The area of my polygon is 1/2 the apothem, which we figured out is 8, multiplied by the perimeter. So let me clean up this picture a little bit. Let me get rid of all these things. All of that was to help me find the numbers that I needed. What I figured out is that the apothem is 8 and that this segment right here was 8 root 3. If that's 8 root 3, then I also know right next to it is 8 root 3, which means each of the sides of this equilateral triangle is 8 root 3 plus another 8 root 3, which is a total of 16 root 3. And the reason I need to know the side length of the entire triangle is because I need the perimeter. So the perimeter of this triangle is 16 root 3 times 3 sides, which is 48 root 3. So if the perimeter is 48 root 3, that's the number that's going to go into my formula, 1/2 the apothem of 8 times the perimeter of 48 root 3. So when I multiply that out, I'm going to get an area of 1/2 times 8, which is 4, times 48, which would be 192 root 3 for the total area of that triangle. Let's do number 2 and see if you get the hang of this pattern. Again, it's a regular polygon, so each of these sides is the same. And since it's a regular polygon, I know the area is 1/2 the apothem times the perimeter. So those are the only two things I am interested in finding. Here again, I am given that the radius is 12. So the very first thing I'm going to do is figure out what is the angle at the top of that triangle, because I know the apothem always makes a 90-degree here. If I can find that angle, I'll be able to find the other sides. So we get that angle from the circle. This time, my 360 degrees is being split by 6 pieces of arc. 1, 2, 3, 4, 5, 6. So that's a 60-degree angle. But remember, the 60-degree angle is here, matching the 60-degree arc. So when I drew in this apothem, I cut that 60 into 30 and 30. So you got to remember to cut that central angle in half. So the angle in my triangle is actually 30. So in the last one we did with the triangle, we got a 30, 60, 90. In a hexagon, you're also going to get a 30, 60, 90. So again, I'll put the numbers on here. Across from the 30 is the side of 1, across from 90 is the 2, and across from 60 is the root 3. So hopefully you haven't forgotten your 30, 60, 90 triangles. So if the radius again is 12, to go back to the short leg would be 12 divided by 2, which is 6. And then to get to the longer leg would be that 6 times the root 3. So those are the two numbers that are going to transfer onto my hexagon. So again, I'm going to erase all this stuff so I can just look at the numbers that are important to me. So all I'm really using the circle for is to find that central angle. Then I use the triangle. So we figured out that the apothem is 6 root 3, and that this length right here is 6. That length right next to it is also 6, so each side of this hexagon is 12, because it's 6 plus 6. So the perimeter is going to be 6 sides of 12, which is 72, and the apothem we figured out was 6 root 3. Remember, the apothem is the segment that goes from the center straight down, makes a 90-degree with the side of the polygon. So those are the only two numbers I need. So the perimeter is going to go here, the apothem is going to go here. So I have to take 1/2 the apothem of 6 root 3 times the perimeter of 72, and that's going to give me a total area of, let's see, 1/2 times 6 would be 3 root 3, times 72 would be 210, 216. I don't have a calculator, so back me up. I'm getting 216 root 3 for the total area of that hexagon. Problem number 3. Nothing is different, but it's a pentagon, so you have to pay attention to how many sides you have. So I have 1, 2, 3, 4, 5 congruent sides in this regular pentagon. Since it's regular, I know my area formula is 1/2 the apothem times the perimeter. So all I need is the apothem and the perimeter, and I can figure out what the area of this this pentagon is. I'm going to go ahead and draw one big triangle again so you can see it. I'm interested in this central angle, which would transfer to be the same as this central angle. What we are interested in is this triangle right here created by the apothem, half the side, and the radius. So let me redraw that over here. It's always this triangle that has the apothem, the radius, and half of the side length. Those are the three numbers I'm interested in. So let's find those. This time I have the circle of 360 degrees being split into 5 congruent arcs, which means each of those arcs is going to be, each of those angles is going to be 72, 72 degrees. So that means this angle is 72, which means this entire angle is 72. But remember, when you draw the apothem is cutting that angle into 2 congruent pieces. So this angle is actually half of 72, which is 36. So I'm given that the side length of this was 10, so half the side length is going to be a side of 5. So this would have been 5, this would have been 5, and I'm going to find the apothem and the radius. This is not a 30, 60, 90 triangle, so I'm going to have to use my trigonometry to figure this out, which means I'm going to have to grab my calculator after all to find this. And naturally, I don't have a calculator nearby. Here we go. I'm going to have to use trig to figure this out. Because if I want to know the apothem would be the adjacent side, whereas the side that I know would be the opposite side, 5. So I'm going to set up a trig ratio that says the tangent of my 36 degrees equals the opposite side of 5 over my adjacent side, the apothem. So if I put this over 1, 5 times 1 is 5, should equal the tangent of 36 times the apothem, which means I have to divide by the tangent of 36 to get the apothem. So the apothem is going to be 5 divided by the tangent of 36. And when I put that into my calculator, 5 divided by the tangent of 36, I get 0.64, which means I am in radian mode, not degree mode, so make sure you check that on your calculator. Let's try it again. 5 divided by tangent of 36, I get 6.88. I'm going to round that to 6.9 for my apothem. So you will have to use some trig, you will have to use some 30, 60, 90 triangles, but the idea never changes. I'm interested in this angle in the triangle inside my regular polygon. That's the angle that will help me find the missing apothem and the perimeter. So the apothem is 6.9, so that's going to go right here, and I have to multiply by the perimeter. Well, the perimeter we could have done from the very beginning. I have 10 sides, I have 5 sides, each of them 10, which is a perimeter of 50. So my area for this regular pentagon is going to be 1/2 times 6.9, the apothem, times the perimeter of 50, and I'm getting 172.5 for the total area of this pentagon.